This is the multiple choice cumulative review. Let's look at 26 here. The graph of f of x is shown. So here's graph of f. Which of the following could be the graph of the second derivative of y double prime? So we know the second derivative function is going to give us information about concavity. So let's just think in terms of the curvature of this graph. Since second derivative function is not so concerned about relative max and relative min, is more concerned about the rate of change of the curve. So we see that this is concave up, but then I know it's very slight here, but you can see that there is a bit of a concave up shape here, right? It doesn't go up, but it's still maintaining that concave up shape. So concave down followed by concave up, which means that there must be a point of inflection there. So I'm going to call that A, just for visual purposes. So that means at A, there's a point of inflection, which means that before A, we're getting concave down, and then to the right, we're getting concave up, right? So I created a second derivative sign line, point of inflection at A, concave down, followed by concave up. Now, if we want to translate this onto a second derivative graph, let's think about what a second derivative graph tells us. The positive y-axis gives us information about where the original graph is going to show concave up. Anything below is going to indicate where the graph is going to be concave down. So we know that between 0 and A, we're getting concave down behavior, right? Concave down behavior. And so it has to reside below the x-axis. We know that at A, there's a point of inflection, which means that the second derivative value is 0, so it must hit the x-intercept. So the graph is going to be here, followed by between A and 2 above. So negative followed by positive. Now the curvature maybe is a little bit more difficult to identify, but at least we know that it's going to be below the x-axis, hit A or hit some x value, not 1, right? Definitely not 1. And then to the right, of A is going to be above. So the only graph that has that behavior, even though we don't have the curvature right potentially, is going to be C, right? C is the only one that has a graph below the x-axis, right, indicating concave down. There's a point to the right of A that is to the point of 1 that is a point of inflection, which is a point that we can visually see there. And then anything to the right is going to indicate where the original graph is going to be concave up. So even though we don't have maybe the shape figured out, but we know the location, this is the only one that fits that location that we know. None of these other ones is going to follow that pattern. Okay, number 27. We have a rectangle with width W inches and height of H inches, where the width is twice the height. So I'm going to create an equation just based off of that statement. Width is equal to 2h. Both W and H are functions of time t measured in seconds. If A represents the area of the rectangle, which of the following represents the rate of change of A with respect to t? So with related rates problem, we'll always write the equation first, and then we find the derivative with respect to time. So we know area of a rectangle is width times height, so W times H. But if you look at our answer choices, all of our answer choices are in terms of H. So we're going to use this relationship that is provided for us to help make a substitution in this problem. What we can do is we can replace W with 2H, because we know that width is twice the height. And then if we make that substitution, we get A is equal to 2H times H, which is 2H squared. So if we find the derivative of A equals 2H squared, then A becomes dA dt, and 2H squared becomes 4H dH dt. And if we have that form, then it matches answer choice D. All right, 28. Selected values of a twice differentiable function. Again, twice differentiable just means it's a smooth curve. The second derivative exists. The second derivative is not going to be 0, so it's going to be a higher degree than just constant or a a linear, it's going to be at least a quadratic or higher. Okay, smooth curve. Derivative is given in the table above. Find the value of this, the limit of this expression. So the first thing we do is when we evaluate a limit, we always just plug in that whole number or that value and see what we get. So we're going to plug 3 in for all the x's. We get 3x cubed, 3 cubed times f of 3 minus 54 over g of 3 minus 1. So 3 cubed is 27. 27 times f of 3, that's going to be 2. So that's 27 times 2. 54 minus 54 is 0. And denominator, g of 3 is 1. 1 minus 1 is 0. So if we get 0 over 0, we know that this is an indeterminate form. It doesn't mean that the limit doesn't exist, but it does mean that there is something else that we can do where we don't see the limit yet, but the limit should exist. So if we see 0 over 0, we know we can apply L'Hopital's rule. So the way we apply L'Hopital's rule is we take the derivative of the numerator, and then we take the derivative of the denominator, and that produces a form that will hopefully lead us to a reevaluation towards a real number. So if we want to find the derivative of this numerator expression, we see two variables multiplied together. We got to go through product rule. So f prime g plus f g prime. 54 will go to 0. And then denominator, g of x becomes g prime. 1 goes to 0. So now we have our results applied after we've taken L'Hopital's rule. So as soon as we apply L'Hopital's rule, we always just go ahead and reevaluate. So we're going to replace all the x's with 3's and see if that will lead us to a real number. So we get 3 times 3 squared. That's 27 times f of 3. 27 times 2 is 54. And then again 27, 3 cubed times f prime of 3. So f prime of 3 is going to be negative 4. So 27 times negative 4. Take those values, we subtract them out, divide it by 2, and our answer is negative 27. So answer choice C. Okay, I added this problem late, so that's why I just called it 28.5. I didn't want to go and change all the other ones that I've created already. So we have an xy plane, order pair 0, negative 2. dy dx is given by 4x over 9y. And we want to figure out of which of the following statements are true. And if we look at our answer choices here, all of our answer choices involves dy dx and the second derivative. So we're going to have to be able to know what the second derivative value is before we can plug in and compare it to 0. So let's go ahead and find the second derivative. To find the second derivative, we're going to go through quotient rule here, f prime g minus f g prime all over g squared. But notice that there is y involved in our derivative, so when we come across y's derivative, we're going to have to involve a dy dx. So we get f prime times g minus f g prime all over g squared. We can go ahead and replace each of our x's and y's with 0 and negative 2. So 0 gets plugged in for x, negative 2 plugs in for y. We clean this up as much as we can, and we work our way down to negative 2 over 9. Okay. So negative 2 over 9 is less than 0, so let's review a couple of things with second derivative test. What the second derivative test tells us is that if our slope is 0, which is the case, right? If I plug 0 and negative 2 in, I get 0 over negative 8, which is going to be 0. But the second derivative value at that point is either positive or negative, then we can make certain conclusions about what's happening at that point. So if the slope is 0 and the second derivative value at that point is positive, then that point must be a relative minimum. So let's say we have a point that shows slope 0. And it's part of a concave up graph. So concave up graph looks like this, right? It's a parabola opening up. So we can obviously tell that the only point that sits on this curve that has a slope 0 must be a relative minimum. Okay. So positive concavity can allow us to make a conclusion that there's a relative min. Okay. Slope 0, if the slope is 0 and concavity is negative, then we know that point must be a relative maximum, right? So we're describing two separate properties about the graph. One is slope being 0, So we see that that's a slope 0. And concave down, that shows the curvature. So the only point that is part of a slope 0 and concave down graph must exhibit relative maximum. Now, if the slope is 0 and the second derivative is 0, then we're kind of at an inconclusive point. We have to use some other methods to help us make a conclusion about what's happening at that point. So, but based off of this, we can conclude that we have slope 0 followed by concave down, so that must mean it must be a relative max. Okay, concave down translates to a visual opening down, so there must be a relative max there. So answer choice D.